Should we wait a few more folks?
Let's wait a little bit. Right, it's streaming.
All right, we are live. What's going on? So Zoom shenanigans again. Okay. All right, so this is a transaction runtime sync. And let's first go through last week updates and what we needed to do. So this is some work that haven't been done. So this is done. I haven't updated the issue with the row count and the difference between RAM and disk, but they're not much different because they don't really account. So Nikolai did some work on measuring effect of writes and reads for Genesis Populate, but he did it on 1 million accounts and it didn't hit as much compactions. Before I started doing this with 10 million accounts, and it still hasn't completed because it both measures bytes written or read and number of instructions. So I'm not sure how long it should go and how many bytes I need to expect. So right now, we're talking about 17 gigs written and 45 gigs read and something like a trillion instructions. 3 trillion instructions. And it's still going on both machines, one with RAM, one with SSD disk. Okay, to do. So I haven't started this, but we'll start soon. This is the app. I haven't done it, so let's transition this one. So I don't forget. This will be done after we have it all things ready. This is done. So runtime config was moved to apply state. RAM disk versus SSD. I still haven't get any results because I was hitting the performance issue with RocksDB. And other issues. So it was either too slow, crashed at the end. So, but also like just with RocksDB, it will not be properly measured with time metric. So I think the decision here can be, we will go with the estimate from Genesis Populate on number of read and writes. We'll see the correlation between number of bytes read and written once it completes, and we will pick some coefficient to adjust all the fees to account for disk. And hopefully it will complete over the weekend, and on Monday we'll have the data. The reason it's so slow is because it runs under a simulator, which measures CPU instructions in addition to disk and write instructions. So it might affect some caching and other metrics. And it does have RocksDB threads enabled plus caching enabled, so it will be more realistic than what we have within a param estimator where we don't have a cache enabled and we don't have threads enabled. So let me put it there. Your cost estimator in accounts. And for runtime, yeah, pretty much nothing blocks the upgrade, except for maybe we want to do this as a feature, but it doesn't matter way we release it. So we can still start working. I think I realized we will face some extra problems such as pessimistic gas. So we may need to disable this pessimistic gas computation by because otherwise, so probably need a background. So pessimistic gas is when you spawn a transaction, we assume that we calculate how many hops it can do on a blockchain. So how far in the blocks in the future it will go, considering it does one function call per block, for example. Then comparing how much gas you have and how much it costs to do this function call, we compute how many blocks in the future you can continue executing this transaction. Then we take an exponent out of number of blocks of some number which corresponds to the maximum gas price increase per block. And then we do slightly higher coefficient to account for potentially delayed receipts. So it's just a hack on how we do this. Now, if we switch to much cheaper function calls, which is about, I think, 20 times cheaper than it was right now, it means the dApps can be 20 times larger, but data receipts are even cheaper. It means you can do a round trip through a data receipt, which is you do a function call and dependency on yourself with another function call, which delays you by 3 blocks instead of 1 block, or like instead of 2 blocks. And since this is cheaper, well, the depth goes from about 64 maximum to something like almost 400 probably. And if you just keep the current coefficient as is, then it will inflate the maximum possible gas by way too much. So maybe we should just go to a regular gas max increase of like 1% instead of what we have as 3%.
Can we,
Plus,
sorry, go ahead.
We need to like fix a few places where it's computed, but it's not that much different.
Yeah. Can we like disable this attempt to predict how many hops would be? I mean, since we're burning all the gas, planning to burn all the gas anyway.
So I don't know if you still want to burn all the gas. It's still kind of like, while it's a good attempt that we wanted to do this, I I don't know if we should um, until a lot of stuff is fixed. So like this is way more invasive change because right now, like every single DevX team or like every single command still attaches boatload of gas, and if you start burning it, our block's gonna be just fully empty.
Like the further down the
And
line we do it, the more damage it's gonna create, right? I mean, we're only
with
gonna have
Mongo, you
increasing
don't
number
need
of
to do
things.
this. So the reason is like whether we can survive before doing it. So the question is, yeah.
And Moonglow can be 1 year from now. So you're saying we bet on not having congestion issues until then?
Right. So we can address it with like adjusting refund cost. So you
But
prepay
if
for the
we
refund
have
cost.
sharding, then it becomes even more likely for this to happen.
Yeah.
Well, we're still limited on RPC side, that not on compute side. So like RPC is currently the bottleneck for taking so many transactions. So in theory, to abuse it, you need to
Well,
properly schedule it. Probably it's
I'm
doable through
not sure. Like
contracts.
if people like spin up their own RPC nodes and stuff, right? It's, I mean, like there could be many RPC nodes, so you never know.
No, well, there's tests that like Michael was doing, and he still faces bottlenecks on certain things.
No, I think no, we saturated the blocks. No, it's I don't think the RPC is the limit there. Like we were able to get 1,000 TPS, right? So like the blocks were fully saturated, so RPC is not a concern there.
Also, like if we're gonna have a large partner who has a contract that they bombard from other accounts, that's gonna be congestion. And
but with sharding, it doesn't address anything. So burning gas does not solve it anyway. So I'm saying that it does very real short-term damage versus like it doesn't address long-term with sharding. So
okay, yeah,
so
let's sleep on it.
Revisit. Yeah, let's see if we can. So for gas priority, it will be like a better addressing this problem, but that leads to like other issues of like receipts and stuff like that. So you'll need to figure out how to resolve it anyway.
Yeah. Okay. So you keep in this progressive the prediction of the gas cost?
Well, it depends on how we do this. You can just adjust the coefficient lower to be like a real inflation without delayed receipts.
Can we actually can we follow the changes with actual, you know, like prediction on like what kind of congestion it would stop, right? Because it feels to me like we trying to guesstimate the coefficients and then hope that it's going to be enough, and then we say it's gonna.
It does not to stop the congestion, just to pay for the congestion. So if you create a receipt without a congestion that is hops every block, then this is the amount of gas you need if your blocks are fully inflated. Like if they kind of full more than 50% and we bump the price every time to 1% up. So this is the adjustment that it's supposed to solve. Otherwise, you run in on deficit of when you prepaid versus what the current block gas cost.
Got it.
The problem with burning all gas is current contracts are not will not decrease the fee. So like lockups and like staking pools, which is majority of our usage.
Why are they not going to decrease the fee? I thought they're going to decrease the fee because we're going to have pre-compilation of the contracts.
Well, they pass for all promises. They still use old fees. So the challenge comes in when, like, because it's hard coded. While new contracts will benefit from lower fees, like all this type of legacy contracts will not. And if any partner doesn't have an upgradable contract, then they will suffer from the high gas expectations. And well, I don't think anyone actually has non-upgradable stuff so far, except for lockups and like staking pools. But that's okay. Lockups and staking pools eventually will. They don't need to be very active all the time. All right. I think that's it from runtime or transaction runtime so far that was happening. I don't think there's anything else.
Wait, so how are we going to adjust the gas computation there?
So we'll go from 0.3 to 0.1 potentially with max upper limit potentially 64. So this, or we don't need to adjust. So we can ignore that part. Or
I see.
So either we can do this, but that's still gonna lead to pretty ridiculous numbers at 53x. So that's not good enough. And like current at like 64 is something like 6x. So we cannot really go to 54x.
I see. Yeah, I mean,
ideally,
400
we
doesn't sound
this,
ridiculous. Like,
ideally, we have this depth built in, but it's probably abusable as well.
I see.
Can we introduce the limit on the maximum depth of the cross contract calls, and that will solve like a lot of problems?
No, it has the issue as well. It's like you can abuse it by blocking some call in the future by depths that's old contracts do not expect.
Okay.
Yeah, if you had like two different types of gas, one for like compute and one for cross contract calls, that would be nice. I just don't know how to, whether it makes sense. Because number of dependencies and promises, well, that's different type of promises. It doesn't matter. All right. Yeah, let's just go with something like this instead. So let's just just limited to 64 hops as it right now.
All right, cool. Should we?
Okay. Yeah, I'll think about this if there's anything else. And okay, let's go through to this. So this is, I'll start working. So this is coming. So this is not happening. Okay, cool.
Well, thank you. We're taking a break.
Mhm.
Thanks.
Hey everyone.
Hello.
I guess we are ready to start. I guess it will be quite short today, but we have a lot to cover on the indexer side anyway. So I'd like to give a chance for Bogdan to bring us an update on this side.
Okay, let me think. So for the indexer for Explorer side, it looks like we have almost finished all the plans we had for the current milestone, except the state changes, because we have discussed it later, like today, and decided to move it to the next milestone. Mostly we were working on improving stability of indexer, adding implicit accounts support. Currently access keys is under review. PR is ready under review. And overall, indexer for Explorer is almost finished and ready. At least Explorer team was introduced with a new database and new backend, and it is possible to start re-implementing to the new backend. Unfortunately, we currently syncing testnet from the Genesis with archival node, and it's way too long. 38% of blocks currently. Hope it will finish after weekend. I guess that's all. Maybe Troll have something to add.
So what is the state for mainnet indexer right now? Is it fully synced?
It should have. Sorry, haven't looked for a day. At least, give me a second.
Yeah, so
yes, it is synced and tries to work.
Cool. Yeah, so we
Wait, you fully synced the archival one for mainnet?
I'm not sure about archival actually.
I thought we were having
Yeah,
archival
we planned to make it archival, and we received a backup for mainnet to speed it up. Yes,
okay,
it is the archival one. Yeah, so we're
okay, great. Yeah,
quite good.
Yeah, so the testnet like turned out to be not archival, and we are currently resyncing it, but it's much shorter. It has much shorter history, so it, like as Bogdan mentioned, it's halfway there. Should be synced over the weekend, I guess. Overall, the stability, as Bogdan mentioned, is pretty good and quite solid. But like it was working for like since Sunday, but overall, like we anticipated like some issues in the indexer itself, and none of them happened at all. So that's pretty nice and neat. Great work, Bogdan, by the way.
Yeah, thank you.
Yeah, and so as Bogdan mentioned, we unblocked Explorer to do this migration, and Ifan is looking into the data structure, since we had to change it, not quite a lot, but still significantly, and expose the scope, introducing execution outcomes and receipts, and more details, like all the way through the data structures. But yeah, we still have one unfortunate inconsistency, we cannot provide the exact information about the order of execution outcomes. Bowen is aware
Bowen
of
has
those.
fixed it. If I'm
No,
not
it's I fixed
No.
another issue. No,
No,
that
was
one
another
has
issue.
not been fixed. Yeah. The other one should have been fixed.
Yeah, so
Yeah,
some of our information may get in a inconsistent state. The only reason we get away with it right now is because every block is usually containing just a few transactions in it, and this does not, and they're not concurrent working on the same account. And this way we don't confuse anything in our state, but overall it would be great to have consistent order there. For example, just it is all about the corner cases. When you add and remove access keys, for example, in a single block, is the same access key, you may end up in a weird situation whether it's added or removed, and we don't know what the latest without the order.
Right. Yep. Yeah. Okay. I'll try to fix that soon.
Appreciate it.
But it seems like other than people trying to maliciously attack you, it's like that kind of thing. It's not very likely to happen, right? Like you add and delete.
I don't think it's an attack vector. It's more like consistency overall, and
right.
Not only we as a explorer and wallet.
Oh yeah, I understand.
Use indexer, but also other people. They
right. Yeah, makes sense.
Be consistent. Yeah, on the Rosetta RPC side, there is a small update there. We had a meeting and we had some chat with the team behind Rosetta, and they implemented is essentially still extending the scope of Rosetta. So they introduced the call endpoint on Rosetta spec to enable view calls. To essentially, what they want to achieve is to be able to view the lookup information, and we will need to implement it to unlock them. Their phase 2 implementation. So that was under discussion for previous week, and this week they released a new spec having this very generic endpoint, allowing us to be very flexible there. But still, the main focus would be to provide a sane flexibility while still allowing them to specifically view the lockup balances and stuff like that. That's, I guess, all from node interfaces right now. Unless I forgot something.
Cool.
By the way, I wanted to clarify whether where the near SDK and all the SDK fall into. Is it node interfaces or it's a separate work group?
So we're right now making some reorganizations in terms of who is working on what. Specifically, it's Eugene. So he's working on the runtime, and we're thinking about expanding it to runtime applications. So nearest decay can be this component. I think I might have said it even before, which is like on his side, but at the same time it's called by the node interfaces. At least because we need someone like you with like deep Rust experience. So yeah, consider nearest decay to be like column component, where Eugene would come in and say, we need this feature for nearest decay, right? He would say, oh, we need like payable annotation. We need this kind of trick to add there, because he would look into what our partners need, and he would, understand their needs and say, we need this thing because they expect this to be in Solidity and we don't have an analog there. So he would have definitely like a product perspective there. But how it's going to be implemented, it can be him, it can be like node interfaces team, it can be bounties. We have some external contributors coming, and we need at least 2 people who would be co-owning it anyway. And we probably should start with someone who's experienced with Rust, like deeply experienced, because it's all microsystem there. So it's probably gonna be you and Eugene co-owning it.
Right. Yeah, I guess. Yeah, I guess that's all from my side. If we don't have any questions, we can just call it a day.
Thanks a lot. Let's just hang here until we have a VM meeting in 15 minutes.
Yay.
I need some intermission music for these videos.
Okay, bye guys.
Bye.
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 Alex, do you want to kick off?
Yeah, we can do it. Do we have everybody here? Eugene, okay, Mike, Peter. Hi, Peter. Thanks for joining us. And Matt, okay. Let's do it. I believe that starting from today, it is going to be me who is going to document everything that we are going to discuss on this calls. So yeah, I'm going just to start the screen screen sharing. Just a second.
By the way, we're streaming to YouTube publicly. Just to
Sure. Okay, so I need to sorry for this, but I need to reload the Zoom because of the privacy, the security and privacy settings, Mark. Okay, give me just a second.
Okay. How's everyone doing?
Pretty good. TGIF.
Yeah, good.
Yeah.
Yeah. Just as a heads up.
What?
Oh, I've got to drop off halfway through. I have to go talk to a core contributor, but yeah, well, I need to talk to Alex Shevchenko.
Okay.
Shevchenko. Ah, that's recorded. I hope I said it right.
Okay, I'm back here. Yeah, let's do it. Okay. So can you see it?
Yes.
Okay, that's great. So let's do the status update. What I think that maybe in some not too distant future, we are going to change a little bit the way how these calls are done. Maybe a bit more focused on the review and the things that were planned on the last calls, and then also sharing some plans on the another calls. But for now, let's just stick with updating on anything that you think that is important for this call. Okay, so if you don't mind, let's go in the same like order that was during the last call. So Mike, can you do the update from your side?
Cannot hear you.
Mike, are you here?
Yes. Okay, there. Hey,
Okay.
folks. Sorry. After 2 failed implementations, I found there were 2 places I found ETH Vigil, and the EIP itself for 712 had a implementation of how to basically recover the address from a signed message, and both of those, once implemented, were recovering the same wrong address once the message was nested, which was very strange. But I think the implementation was kind of like correct, if you will, in the sense that they were returning the same one. I discovered that there's a MetaMask library called ETH SIG util that actually will successfully recover that address once the message is nested. So that took a little bit of trial and error. 3rd time was the charm on that. So I figured that out. I still have the basic relayer, which is an Express.js app going. I refactored that to use TypeScript this week. As a note, I also saw a little bit of issues with how migrations work, and I added some troubleshooting to the README, which is basically like once you're compiling your contracts, and then you make changes and try again, you may need to blow away the ABI files. And so this is a possible hurdle and red flag, but I'm not sure yet. So I added some troubleshooting and discovered that the hard way. In terms of RLP encoding that we'll be needing to do, looked into that. And again, I started with a library that didn't work as well. The Ethers.js RLP was not as great as the Ethereum.js RLP package. So I figured that out the hard way. And so once we do the RLP encoding for arguments, that'll be the library we want to use as Ethereum.js's.
One small note. So maybe we should share this LP our RLP library investigation with the bridge team, since
Okay.
we also have some RLP library in there. And I mean, we went through quite a bit of pain trying to pick the right JavaScript libraries to work with Ethereum primitives. So there might be some learnings.
Okay, thanks.
Okay.
And currently, there's just kind of two more items here. Currently, we've been having recent discussions about the best format for what the user should see in MetaMask when they are going to sign something. I am still focusing in on the very basic pet shop example. And what we don't want to have happen is someone gets a pop-up on MetaMask and sees, you know, RLP encoded items. We would like them to see something human readable. And I don't have a clear answer on the best way to do this yet, but we want to have the interface be like as understandable as possible. So that's sort of like an ongoing kind of concept here.
Mike, isn't it some kind of an ERC? I don't know, maybe 712. That is saying about how you need to structure the messages that you are signing. So the MetaMask also supports this this ERC, and it like translates everything in the human readable format.
Yeah, right, correct. So that it's a little bit different than that, because so right now I do have a human readable nested structure where it says I am trying to adopt pet, you know, number 14, the ID is 14. I will give you 10 fungible tokens from this fungible token contract address. I am trying to call the function adopt to adopt this pet. And so MetaMask is currently displaying all of that in human readable form. I think where it gets tricky, and I will probably have a hard time answering questions on this call exactly what we should do next. But as soon as that goes, like once you sign that and then that goes into like the relayer and then we talk to the near EVM, the meta call function inside of near core is like expecting it to be RLP encoded arguments, basically. So somewhere along the line, we need to RLP encode it. So maybe it's fine. Go ahead.
Sorry, it's not about RLP encoding. It needs to be ABI encoded. So function call in Ethereum is like the function name is mapped into an integer in Ethereum because everything's integers. And so if you signing a string and passing it into the EVM on the near core side, there's no way for near core to figure out what the string actually means. So the question is how to show a string to the user and pass an integer to the to the signature.
Okay.
And I don't know if this is possible. This is just like we may need to kind of work around this in some other way.
Yeah, I was kind of thinking when the user is signing on MetaMask, we could sort of. Actually, yeah, I think we'll take this offline. I think I understand the problem where like, so we're talking about the function signature, I think also called the function selector. And that will look like gobbledygook in MetaMask. So we need to figure that out. There isn't a library imported to determine that function signature. And I guess since we're on this topic and Ilya's here, I thought that Ilya, you mentioned we need to send the ABI, but we only need the ABI for the function signature, correct? Yeah,
we don't need to send ABI unless we need to send ABI. Yeah. Well, that's what I say. Like, how do we do this? Like the only way I can think of right now is you show a function name and arguments, and then send that as a message signed, and also send an ABI, and we decode and re-encode ABI inside near core. I mean, this is very suboptimal, to be clear. Like, I hope there's a better way, but I don't know a better way based on my research.
Yeah, it feels like an ABI could add a lot of overhead.
Correct.
Okay, cool. So that's sort of like in the next steps section of what I'm working on, I would say. And that's it for me.
Okay. Hey, so I have to drop off in 4 minutes. I don't think we're gonna have time to do what I was hoping, but I just want to put it in everyone's mind of what's going on from the community side towards the EVM. So I'll just be really brief. Number one is there's a contributor who has previously worked on compilers. He pitched, I think Max already heard about this, writing a transpiler from Solidity to Rust. And instead, I'm gonna pass him over here, so you guys will have another person to help work on the EVM from the community side. Number two, we have three total teams who are super competent, who need, or not need, but it would be really helpful if we could create bounties that are EVM specific or bridge specific, that are like really challenging, deeply technical, that we either don't have time to or time to get to with this team, or are like just under your guys' priorities. And then three is I will, in the next week, need someone to help Austin Griffith from the Ethereum side set up an EVM endpoint to deploy some code. It doesn't have to be in sync, it can be async. So yeah, those are my three asks. And then I guess I come bearing gifts with the EVM contributor. I mean, assuming we can, get them up and running.
Peter,
I wanted to put that out there.
Can you spell, who is Austin?
Austin Griffith, spelled AUSTIN GRIFFITH. He's an Ethereum sort of like public figure. He makes really cool tutorials on Ethereum, and he's pumped on deploying one of his tutorials to the EVM specifically. And so yeah, this is fine going public. I know we're on YouTube, and maybe he's watching. Hi, Austin, if he's watching. So he's going to work with us on deploying a pretty cool project that he's built with one of our, I guess you could say one of our community engineers as well, and then publishing that somewhere. So I don't want to get into too many details because I don't want to spoil the plot of the video, but that's what's coming.
I think we need to sync on that.
Okay, great.
Like we discussed in Slack.
Oh, right. Yeah, sure. Just the main thing that I want on everyone's mind is if you guys have ideas for the bounties, that's really valuable. Oh, someone is helicopter mode. Okay.
Okay. So as an action point here for Max to sync with Peter. Okay. On this. But we obviously well, from my point of view, we can deploy this only at the point when we are having EVM, isn't it?
Yeah, sorry, 1 second. Yes, but I think we can set up a private network with the EVM. It's a relatively simple contract. So imagine like if we were to launch Pet Shop, on its own private network or on the private network, we could probably come up with that kind of solution. It can be hacky. It's just for a demo.
Yeah, I mean, we do have a private network already right now.
We just need to make it. It doesn't even need to be broadly user friendly. It just needs to be like specifically demoable, and we need to know the steps that it takes to deploy a new contract. Like I bet, yeah, we can sync offline on that. It's just what steps do we need to go through so that when we do the demo, everything doesn't break, basically. That's what I'm concerned about.
Okay.
Yeah, that's my concern. I mean, that's why, let's sync offline. All right.
Yep, sounds good. But yeah, the thing, like I said, I will reiterate, the thing that should be really important is identifying the work that we can offload to the community. So we'll have a whole new resource, and then 3 other teams that can contribute to this. So I know we're like strapped for resources, but this is something that can amplify us.
Okay, great. Thanks.
All right, thanks for the time, everybody. I gotta drop off.
Thanks, Peter. Okay, Bo, can you update us on the Ethereum EVM gas into the Near gas? Bo, are you here?
Maybe not. Can skip.
Maybe not. Okay. Eugen Kapun, can you update us on the PR? Well, the majority of the code PR Have you been able to take a look at it once again?
Well, I'm currently mostly focused on the bridge, not on EVM. So
Yeah.
say much
Yeah,
about.
I just missed. Yeah, I just confused two agents that are on the call. The other one.
So I'm looking at the EVM. I think most of the stuff is addressed by saying it should be handled by gas. So overall, it seems fine. We just need to verify it, and I don't know how it's actually done since currently gas is disabled. Well, it's not disabled, it's just set to higher limit. So once we have some estimates from both, and we plug it into limits on the VM, then we need to make sure all the findings that we have are addressed. And I'm reviewing the code, and I'll just unresolve stuff that should be handled by gas to make sure we don't forget to test them once we have gas enabled.
Is it the only task that is blocking that PR from merging?
Well, gas is like a major one, but the second one is feature enabled. So currently it's a protocol change, and we decided not to do the protocol change because it will interfere with the release plan. So it will need to be changed to be behind the feature. So I think Bone is not sure about Bone. So I don't know who from chain will implement this feature. Correct.
Do we? So that was something that we have been discussing yesterday. Is there anybody on this call that who knows whom we should ask when it is going to be done?
I actually don't know if even it's like a high priority right now. So
I think it is. I mean, it's assigned to Bowen right now, so probably Bowen is.
Bowen will look into this.
Okay.
Yeah, but I didn't have enough time to look, so I didn't spend enough time. I would say not to have. But it seems like most of this was addressed. So I'll finish it today.
Okay, that's great. I don't know who's also been doing anything on the EVM side.
I can give some update on gases. So last Friday I was take a day off. So from last Friday I did figure out the deploy contract volatility is because we didn't account for both EVM gas and EVM contract size, because the deploy step is actually both a state change that depending on the size of the contracts, and also calling the constructor of the contract. This part is reflected by the EVM gas used by the EVM crate, and counting both two and do a linear regression, the deploy contract cost is not volatile. And then I adding 200,000 accounts, both with one EVM contract as the base point to measure all the cost. Because the cost heavily depends on the size of the state. But if the size of the state is pinned, all the cost is now very stable. And the final thing is, so I also try to measure the pre-compile functions like SHA-256 and the other two, like identity. The cost should the cost, as Ilya pointed out, should not be fixed, but instead depend on the size of the input. But my result found is like only a few hundred difference in CPU instructions, in number of CPU instructions in like two in different size of inputs, like per byte. So when convert this number back to EVM gas, that's less than 1 EVM gas per byte. Since our EVM gas per byte is integer, so it's often just 0. So I want to discuss here whether we still want that, since we would expect like the hash of an identity input of the function input is usually less than 1 KB, and that multiply the EVM gas per byte for that precompiled function is still like very trivial.
Okay. Anybody any thoughts on this?
Well, so the reason why we needed to scale is exactly what Eugene mentioned, is because if you pass a 100 megabyte long input, then the data allocate, or like there's a length, like you don't even need the input, long input. You just say, I want, 100 billion terabytes of input. Like there's like multiple functions that take lengths as one of the parameters specifically to calculate gas. And so the reason to use it is to pretty much make sure you will not be charging, you will not be trying to allocate 100 tera gas to 100 terabyte of memory. Now, I don't think we need, like, if we already mapped our EVM gas to our stuff, why don't we just use the gas calculations of the EVM of the Ethereum in the first place? Like, why don't we just take the gas pricing cost calculations from the Open Ethereum parity client and just use that?
So EVM precompiled functions its cost is deducted in a different way. It doesn't being exposed by the EVM crate. Instead, it's when EVM interpreter interpret EVM contract, and when it see each of the precompiled function, it will try to deduct calc them as the EVM gas you give in the config. So once I found the near cost of these precompiled functions, I need to convert it back to EVM gas, and let the interpreter deduct the EVM gas when it interprets this contract. And
I just linked you to the code you should just take.
Okay.
So sorry, I probably missed this. What is the solution here to this problem?
So there is a calculation that Ethereum uses for all of this.
Yeah.
Like, this is implementation that's live right now, that's been securing, billions of dollars, and so we just can use that. And then we're already rescaling Ethereum gas to our gas, which is what Bo already did. So this way,
the
we
challenge
don't do
is
anything.
like, let's say we are faster than Ethereum gas, then the limits might be higher, and depending on how much more gas we can process within a second, and that will affect our limit. And it might blow up the memory, just because if it was not possible on Ethereum and it was limiting to 100 megs before, and let's say we can do 10x, then it will be 1 gig on us. So we need just to make sure that the limits are adequate for the max RAM that it can allocate and stuff like this.
Should we just keep the EVM gas limits, like it's coming in into?
Oh, maybe on the max transaction size that will prevent it. Then yes.
Yeah, that's what I meant. Like not even
Okay.
transact, but receipt size, right? Specifically coming into EVM.
So you can just say that the maximum gas that it can spend is X, and then
Yeah.
the rest is refunded.
Yeah.
Yeah, the thing you sent me doesn't. We are not sure it will be compatible with our near to EVM gas conversion rate, because different EVM gas, like on the different circumstances, it has different conversion rate. For deploy contract and call function, it might be different than this precompiled function EVM calls. So the way we did is probably more accurate, as we calculate the number of CPU instructions and use that to reflect how much EVM gas it should be.
But you realize, right? You see, like I sent you specifically for mod X pricer, and the logic there is not easy. It's pretty complex.
Yeah.
Like and we need to represent this logic on our side. So I think the easiest way is represent this logic, and then you can still maybe adjust if you want. But like I don't think it makes sense to, like, the point is, it's a baseline plus 96 is above that, like that all logic needs to be represented.
Okay, so it's not a trivial like cost per byte. Instead,
No,
I should
it's not.
find.
It's not even just cost per byte. Like as I said, some of the input contains the lengths of the allocated memory.
Yeah.
That needs to be having. So you can you need to actually read out the bytes of the input and based on them define some rules. So.
Got it.
Mm-hmm. Okay, so the calculation. So once again, just to wrap this up, we can use the existing implementations that are used by Parity in their Rust client that are doing the calculations of the gas in the EVM, and we just need to use the same thing and then rescale it to the near gas. Is this correct?
Yeah.
Okay, great. Any additional updates here?
How is the timeline planning going with EVM? What are the next steps to come up with the timeline?
Yeah. So I created like a very draft version of the EVM timeline, like the approach how to do this. We have not discussed it with everybody. So let me do the following. Let me share with you the approach that I have in my mind right now. I'm going to share it in some kind of. I'm going to put it in the document and share it with all of you. And then you would be able to comment this. And it is just like the staged approach without the dates. Let's first agree on the stages that we will have there, and then we would be able to discuss the dates and maybe set some milestones, so we can do this. So it is already created. So I actually shared it with Ilya today earlier. Yeah, so I'm going just to send it to everybody, and let's see whether it fits our vision, how we need to proceed. Okay.
All right. Seems that we also need to add an action items to sync with Bowen on rolling out the feature flags with EVM.
Yeah.
And like exactly what kind of coordination we're gonna have there.
Yeah, I just wanted to do that. Yeah, I was thinking on how to restructure this list. Yeah, but let me just. I'm going to put this on me. Since this is a really blocking thing for us right now here. Okay. Any other updates? I believe we are running a little bit out of time.
Not for me.
Okay, great. Yeah. Okay, great. Well, then thanks everybody for joining this call. And yeah, see you in a week.